Sizing the hot water circulating system. Hot water circulation. The objective of the design of a hot water circulation system is to have hot water of equal temperature readily available at any fixture as needed. Hot water supply piping, whether insulated or not, transmit hot to the surrounding lower temperature air by convection, radiation, and convection. If the water remains stationary in the piping for any length of time, its temperature will drop to a level which is unsatisfactory for the proposed use. This cold water must be withdrawn before hot water at the acceptable temperature appears at the outlet. This results in vast wastage of water and is inconvenient for the user who wants his hot water immediately. The additional cost of installation of a circulation system and a reheating water to compensate for the heat loss in the piping are not warranted for building with length of run from the hot water heater to the furthest outlet is less than 100 feet and where the building is 4 stories or less. So, pwede siyang wala, pwede meron. So, yung mga PPR, wala na yan. Ng hot water circulation yan. Supply lang. Okay? System types, hot water supply and circulation piping systems can be classified into 3 general classification: the upfeed, downfeed, and combined upfeed and downfeed. The heater location can be at the bottom or the top of the system. Provision must always be provided at high point of the system to relieve air which may collect and adversely affect the circulation system. So figure 14 and 15 illustrate the hot water circulation system. Ito. This is the hot water. Andito yung heater mo. So this is the upfeed. Heater located at the bottom. Ayun ang heater mo. So pataas siya doon. Tapos, itong pababa na to, ito yung circulation. Recirculate mo siya doon sa system. Meron, hindi lahat, konti lang. Yan. Para ang calculation to is kung ano yung heat loss niya. So, convert mo sa gallons per minute sa flow rate. Makuha mo yung pipe size nito later. Mag-base ito sa heat loss nito. Pero kung yung heat loss mo mang liit, tulad ng PPR, doon din na nito. Okay? This one naman is downfeed system. Yan. So, pag wala kang recirculation, tanggal mo lang to. Hanggang dyan ka lang. Wala to. So, andito yung heater mo, supply mo doon, punta dito sa mga valvula. Supply ka na sa mga rooms. O, kung may heat loss, yung flow rate na sobra, yun yung kukompensate doon sa heat loss mo. So, 15 hanggang 16 pala. 15, 16, 17, 18, 19. 19. Sabihin ko lang. Wait na And hanggang 19. 16, combination upfeed and downfeed system. Heater located at the bottom of the system. The heater, combination ng upfeed and downfeed. Ito. Supply ka dito, then pabalik naman doon. Kung wala kang circulation, so wala to. Ito lang. Ito naman combination downfeed and upfeed system. Heater located at the top of the system. Yan. Saan yung upfeed dito? Naman to downfeed doon. Okay, next. Downfeed system. Heater located at the top of the system. Then, so ito ang combination na Nabaliktad ng libro. Libro to kasi niya nakalagay sa kanya. Diba? So, ito yung downfeed. Ito yung combination ng downfeed and upfeed. Yan, pataas, diba? Yan. Okay. Okay. Next, feed system, heater located at top of system. So, lahat to pataas. Ayutin natin ha. Ayusin. So, tama na. Lahat to, downfeed. Ito may mga araw ay mga branches. Ito tinan mo, downfeed lahat yan. So, ito, downfeed then up. Okay? Yung librong pinupyan. So, ito lahat to upfeed. So, ito yung circulating pump. Punta doon. Ibang size nito, maliit yan. Pag-circulate lang. Para yung dadang kasi nga dyan, sa flow rate, may equivalent yun sa heat loss ng pipe. Pag PPR, so negligible lang heat loss doon. Pag malaki, wala na heat losses yung PPR pipe na nakapipe. Plastic. Pag GI, sa copper, yan, malaki ang heat losses na. Okay? In an upfeed supply riser, the circulation riser is always connected below the highest outlet so that every time the outlet is open, any air which may have collected at the top of the riser is relieved. It is also recommended that the connection be made above the lowest outlet on a downfeed riser. So any sediment which might collect at the base of the riser is passed out when the bottom outlet is open. Sizing. Proper sizing of the hot water circulating system is essential for efficient and economical operation of the hot water system. Circulating system to, iba yung supply system ng hot water. Supply system sizing at dinaan natin doon sa cold water. Oversizing will cause the expenditure of extra money on material and create additional heat losses which in no way contribute to a more efficient operating system. Undersizing will seriously hamper circulation and thus adequate hot water will not be immediately available at all times. The hot water circulating system is designed to maintain the hot water at the point of use at required temperature at all times. To accomplish this accurately and economically, the rate of circulation in the piping and the size of circulating piping to obtain that rate must be accurately determined. Three basic factors govern this determination. A, the heat loss rate of the piping. B, temperature differential at which the system is to operate. C, the allowable friction head loss in the piping. And it is assumed that the hot water supply system, including the mains and risers, have been properly sized. So meron ka ng size. The sizing of the hot water circulating piping can now proceed. The step-by-step procedure will be listed and then the system will be thoroughly discussed. Finally, the procedure will be applied to actual system. Procedure. Calculate the heat A. Calculate the heat rates of the hot water supply piping. Letter B. Calculate the heat loss rates of the hot water circulating piping. So, paano mo gawin yun? Wala kang pipe size niya. So, example na lang, makita nyo. C. Calculate the circulation rates for all parts of the circulating piping and the total circulation rate required. Determine the allowable uniform friction head loss and the total head required to overcome friction losses in piping when the water is flowing at the required circulation rate. E. Calculate rates of flow for various pipe sizes, which will give the uniform pressure drop established in step 4 or D, and tabulate the result. F. Size the system based upon tabulation set up in step E. G. With sizes as established in step F, repeat steps B and F as a check on assumption made. Now, this procedure may seem cumbersome and time-consuming, but once the procedure has been established and applied a few times, and the necessary circulation have been set up in permanent check form, it will be found to be a simple and rapid method of sizing. It is the only way to be assured of accurate, dependable, and economical result. Each step of the procedure will now be thoroughly discussed. Okay. Calculate the heat loss rates of the hot water supply piping. Domestic hot water is still generally distributed at 140 Fahrenheit. Okay? The BTU per hour per linear foot at 140 Fahrenheit, water temperature is 70 Fahrenheit room temperature for various pipe material, bare and insulated is given in table 4. So, piping heat loss. Ito yung schedule 40 steel, bare copper, type K copper. Ito yung bare pipe, brass. Kung may insulation, ito nakitingin ka dito. 1/2 inch fiberglass. Ito yung nominal pipe size. For PPR pipe heat loss, if used, so ito yung link na makikita niya doon. Pagdating ng lumalaki dito, naging zero siya. The values for insulated pipe are derived figuring the insulation to be 1/2 inch thick fiberglass. Tables for other type and thicknesses of insulation can be compiled. To obtain the heat loss rate of the piping, multiply the length of the piping by the appropriate values found in table. Length kasi yan, ba? Linear foot. So, the latter assumption is favored by the author and seems more compatible with the procedure outlined. By utilizing this assumption, the heat loss rate for the calorific piping can be established for all parts of the system at the same time that the hot water supply heat losses are established. The calculations are thus simplified in this video. B. Calculate the heat loss rate or of the hot water circulating piping. At this time, sizes for any part of the circulating system are not known. An assumption must be made in order to use the values in table 4. There are two choices. A. Assume sizes to the circulating mains equal to 1/2 the size of the accompanying hot water main and assign a 3/4 size to all circulating sizes. To all circulating riser. It will be assume the heat losses of the circulating mains and risers to be 2/3 the heat loss of the accompanying hot water mains and risers when both supply and circulating piping are bare or both are insulated. Assume 1 1/3 the heat loss of the supply piping when the supply is insulated and the circulating piping is bare. Okay. So normally, both naman some insulation. So, or both bare dapat parehas. So kaya gagamitin is to turn the heat loss of accompanying hot water mains. Yun ang i-assume mo, yung heat loss doon sa circulating water piping. C. Calculate the circulation rates for all parts of the circulating piping and the total circulation rate required. To find the required circulation rate in any part of the circulating piping, the heat loss rate for that part is divided by 10,000. This will give gallons per minute of flow required. So the 10,000 figure is obtained from the following manner. Wait. So 1 gallon of water weighs 8.3 pounds. 1 BTU is equal to the heat necessary to raise 1 pound of water 1 degree Fahrenheit. It is good practice to design a pump circulation system at a temperature differential of 20 Fahrenheit. Yan. 20 Fahrenheit ng delta T. Now, for a circulation rate of 1 GPM, 8.3 times 20 is 160 BTU per minute. And 160 BTU per minute times 60 minutes is 960 BTU per hour. For ease of calculation, 10,000 BTU per hour can be used without introducing a significant error in the result. If the total heat loss of all piping is 300,000, then the required circulation rate to overcome this loss is 300,000 divided by 10,000 is 30 GPM. Now, D, Determine the allowable uniform friction head loss and the total head required to overcome friction loss in piping when water is flowing at the required circulation rate. The uniform friction head loss can be established in two ways. A. So may kulang. Wait. Yung two ways, nandito na yan sa liig. Take the circulation rate established in step C and select an efficient pump of that capacity from a manufacturer's catalog. Pump required for the pump selected, not the discharge head. This there will be the total head available. So maghanap ka ng catalog para kaya kang basihan. Divide by the equivalent length of the run of the longest run of piping to obtain the uniform friction head loss. Saan ang technique? The longest run of the piping is taken from the farthest point of the connection to the hot water supply and then back to the source of the hot water supply. The length of run of the hot water piping is not included because the pressure drop in hot water piping is significant. Okay. The size of hot water piping has been established for extreme high quantities of flow as compared to circulating flow, so that when only the circulating rate of flow is occurring in the hot water piping, the friction loss is extremely low and can be ignored. The hot water piping, bala naman yung main pump. The measured length of run is the developed length. To obtain the equivalent length of run, the resistance of the valve, fittings, etc. must be converted to equivalent length of pipe. Since sizes are still not known, a reasonable assumption is to 10% of the developed length to the measured developed length. Yan. First estimate lang to pag wala yung mga sizes, tapos ulitin mo para makuha mo na yung size. Diba? So, F, establish the uniform friction head loss empirically. Ito yung second method. The uniform friction head loss can be selected for a minimum of 1 foot per 100 feet to a maximum of 10 feet per 100 feet. This will permit economical pipe sizes at reasonable velocity of flow and still not create too great discharge head for the required circulation pump. Select a circulation pump of the capacity established in step C and a discharge head equal to the selected uniform friction head loss times the equivalent length of run divided by 100. So, ito yung unang method, ito yung pangalawang method. Ito, kukuha ka ng available pump dito, mag-base ka ng, ng head loss. Magsiset ka. Or, meron pang iba dyan is yung velocity. So, check mo yung velocity. G, now calculate the rates of flow for various pipes which will give this the uniform pressure drop selected in step 4, step D. This can be done from available charts or can be calculated by means of the following formula. So ito yung formula. For brass or copper, Q is equal to 40, D exponent 2 and 1/2 times the square root of H over L. For galvanized iron or steel pipe, Q is equal to 28.3 times D exponent 2 and 1/2 times square root of H over L. Q is the gallons per minute, and D is the actual internal diameter of pipe in inches. H is total head available for friction loss in feet. L is the equivalent length of run in feet. So the system in accordance with the values established in step E. I, when size is now established, the exact head losses can be determined and the exact equivalent length of run can be determined. The accuracy of the internal procedure can thus be checked. So ulitin na. The application of the above procedure to an actual 24-story building will now be made. So figure 20, the next slide, shows the ratio diagram of the installation. So the length of runs are shown as well as the sizes of hot water piping. The length of the runs are shown. The material of the entire system is brass. Both the hot water and circulating piping are insulated with 1/2 inch thick fiberglass. The run-outs from the mains to the riser are all 10 feet in developed length. The hot water circulating system is to be size. Table 5. Ito. So this is the riser. Okay. So, ano natin to? So, hot water piping. So, table 5. Explain. From heater to riser 1, and distance mo is so gamitin natin yung table 4, 5 meters. So una mo is ito 4 inches from heater to riser 1, di ba? Itong distance na to, ang ano mo dyan is 20 feet. Ayan, nakalagay 20 feet times 46. Anong size na 4 inches siya eh? So, insulated pipe, so 46 inches. Yan. 46 ang value ng heat loss. So, kaya nga sa nag-20 times 46, so 920. So, sa hot water circulating piping mo is 2/3. The total of 920 is 613. So, this is now the GPM to overcome heat loss. So, 1,000, i-add mo itong 920 sa 613 is 1,550 divided by 10,000 is 0.1533 gallons per minute. Yan. Oh. Riser 1 to 2. 1 to 2 is 10 feet. So 4 inches din siya. So nakuha natin is 4 inches. So magiging 460. Total ng 460 is 307. I-add mo 767 divided by 10,000. 0.0767. Diba? So 1 to 2 hanggang sa 10 to 13. 13 to 12, 12 to 14. Yan. Okay, baliktad yun. Tingnan nyo na lang dito. Ayan. 10, 12, 10, 13, 12, 14, 6, 6 yan ang number niya. Okay? So, risers 157. Naman tayo. Ito yung total niya sa mga riser ay ito sa baba. Risers 157. Itong pataas, verticals. 157, parehas siya kaya. Times 10 na lang. 157, 157. Typical siya parehas ang 5 size na tsura niya. So, meron siyang 10 plus 160. Sabi 160. Ang 10, ito, to the 10. Tapos, 9 times, pagmula sa dito, 1, 2, and 1 half, hanggang dito. So, this is mga 160. Yan, times 32. Ayan. So, this is 2 and 1 half. So, meron kong 32. Piping heat loss. Yan. Then, sa 2 inches naman, itong patas sa 2 inches, that is 27 feet, times 28 is 756. At meron pa siya dito 1 and 1 half. Saka 1 and 1/4 ba sa dulo? Ayan. So, yun. So, 6 sa dulo times 21, ito yung 1 and 1/4 is 126. I-add mo, 6772. Tapos siya. Tapos siya. So, 3 times 6772 is 20,316. So, total niya is 4515 o times 3, 13,545. So, add mo to, 6772 saka 4515 is 11,287 divided by 10,000. is 1.1287 per riser. BPM. So riser 2, 414, ganun din. Natin mo lang yung mga pipe size niya. Iba 2. So iba naman ito ganito. 2.5, 2. So dito ang 2.5, 2 ang layo. So mag-iiba nga siya. So 2, 4, and 14 pare-parehas. Ganun din. Ayan mo siya. Riser 3, solo lang siya. Ganun din. Riser 6, di ba rin? Riser 8 and 12, so pare-parehas siya. Ayan, total lang. Riser 9, 11. So yan. I-add mo lahat yan. Ito na yung mga total heat loss mo. 19,964 saka 56,664. So ito naman sa may magpapasok sa pipe to. GPM. Okay. Steps A and B are done simultaneously by setting up the calculation in tabular form from a grand total of 99,984 plus 66,664 or 100,648 meter per hour. Now, the total circulation rate required is then 166,648 divided by 10,000 is 16.7 or 17 gallons per minute. That's it. Maliit. Now, select a uniform head loss of 2 feet per 100 feet. The longest developed length of run is from 23rd floor ceiling at riser 11 down to the cellar, yung basement, and back to the heater. The developed length is 200 feet riser plus 10 feet run out plus 475 feet yung main is equal to 492 feet. So equivalent length of run is 492 plus 0.1 times 492 is equal to 541 feet. The 0.1 is yung 10% allowance. Now, the total head required to overcome friction head losses is 2 times 541 over 100 or 10.82 feet. Now, select a circulation pump which will deliver 17 GPM at a discharge head of 11 feet. Yun. Base dito. Ito mga bumalik dyan. So, yung circulator pump mo ito. Circulate nyo doon. Yan. Balik dito. So, typically, na ang ilalagay mo dito. Pero pwede rin kang mag-iba-iba ng pump size. Okay? Para tipid. Pero kung hindi man, pwede ka na mag-typical na para madali sa design. O, kasi mapura lang yun. Pag iba-iba, minsan nagbabalik-baliktad. So, mas maganda ng typical. So, E, calculate the rates of flow for various pipe sizes which will give a uniform pressure drop of 2 feet per 100 feet. Q is equal to 40 times d exponent 2.5 times the square root of S over L is 40 d exponent 2.5 times the square root of 2 over 100 is 5.656 d exponent 2.5. All values can be selected from tables of pressure drop. So ito yung table mo, 1/2 inch is 1.8 GPM, 3/4 inch 3.5 GPM. Ang hindi itong 3/4 ang substitute mo doon, meron tayong table doon ng inside diameter. So 1 inch 6.6, 1 and 1/4 12.4 GPM, 1 and 1/2 18.3, 2 inches 34.6, 2 and 1/2 56 GPM, and so on. So dito, itong bawa 1/2, yung inside diameter niya ang isusubstitute mo dyan. Okay? So F, from the tabulations for step 1, 2, 3. Wait, what is step 1, 2, 3? From the tabulation of values for steps A and B, ito yan. Ayan yung tabulation. The last column, ayan. Ito shows that no riser has a circulation rate exceeding 1.8 GPM. All risers can therefore be 1 knot in size. It is recommended that a minimum size of 3/4 be used to accommodate the decrease in pipe area due to accumulation of deposit with age. So, instead na 1 knot, yung natin 3/4. Gawin 3/4. Recommended lang. Starting at riser 11, add the circulation rate of each riser as it picks up by the circulating main plus the circulation rate of this portion of the main. All values are obtained directly from the tabulation setup for steps A, B, and C. Sizes are obtained from tabulation setup for step D. Dito yung tabulation setup. Nandiyan pag nag-more than ka ng 1 knot, about sa 3/4 yan, 3.6 na, so magiging 1 inch ka na. Sample yan Yan. So, riser 11, ito, 11, then 9 to 11. Ito, idagdag mo tong 11. So, magiging, itong dulo, di ba? Ito, yan. Riser 11 yan. Tapos, itong 9 to 11. Ito lang tayo muna. Total niya ng losses niya is 0.97, 0.9689. So, 0.97 yan. Nakakap lang. Plus 0.12. Ito, 0.1167 is 0.12. Total mo is 1.09. So, use 3/4. Then, riser 9 plus main 69. Itong 69, kasi itong linyang to, maghahalo na itong riser 9. Tapos, ito naman na main na 6 to 9. 6 to 9, yan. Okay. Kuha nyo na. So, that is 1.09 plus 0.97, riser 9. Ito. Plus 0.11 is riser main 6.9. Hanapin mo dyan. Ito. So, this is 0.11. Magiging 2.17. 3/4 pa rin. So, dito naman, 2.17 plus riser 6 plus main 14.6 is 2.17 plus 1.2. Riser 6, 1.19. So, 1.2. Plus 0.16 yung 14 to 6. This is 0.13. 14 to 6. 0.16, tama. So, add mo siya is 3.53. So, you can use 3/4 pa rin. 3.53 plus riser 14. 3/4 or 1 inch pwede. Plus main 12 to 4 is 3.53 plus 1.07. Riser 14, 1.07. Tapos main 12 to 14. This is 0.13. Okay, 0.1267. So, this is now 4.73. So, 1 inch na. Tapos ka naman 3.5 or 3.6. So, wala na yung 5 gig. Wala ka na makikita 5 doon. So, 4.73 plus riser 12. Main 13 to 12. 4.72 plus 1.1 plus 0.13 is 5.96. So, 1 inch. So, then 5.96 plus riser 12, 13 plus main 10 to 13 is equal to 5.96 plus 1.1 plus 1.13 is 7.19. So, this is now 1/4. 7.19 plus riser 10 plus main 8 to 10 is 7.19 plus 1.1 plus 0.13 is 8.42. 1 and 1/4 na. And so on. So, lahat yan. So, meron ka ng size na 1 and 1/2 na pinaka-heater. So, andito yung heater mo, tsaka yung pump, nandyan din. Yan. So, now, with these sizes, step 1 to 6, so. Now, with these sizes, step A to F cannot be performed with the necessity of any assumption. Without the necessity of any assumption and the accuracy of assumption made can be checked. So, using the sizes, So, balik kita na. I-actual mo na yung ito. Hindi na sa 2/3, kundi based na to sa tunay na heat loss na. Okay. Next is PPR piping. PPR is a straight and rigid cylindrical pipe made from polypropylene London copolymer plastic produced through a continuous explosion process. They are commonly offered in green or white color and outer diameter sizes ranging from 20 mm to 100 mm, making the pipe walls far thicker than PVC. So given to, pag nag-ano ka ng pipe plus 1 na, is, ang ano niya, outside diameter is 20 mm. Okay? Pag may convert ng 20 mm sa inches, magiging 3/4. So sabi, ang pipe mo na equivalent is 3/4 inch. Lalaki na yon kasi hindi naman na magiging 3/4. Sipin mo, kung 3/4 ka, dapat sipin mo na outside yon. So 20 mm is outside diameter. Okay? So this is equivalent to 1/2 still pipe, nominal pipe size. Making this thicker. PPR is accompanied by a series of connection, fittings, parts, and accessories available for every pipe diameter. PPR piping system can remain functional for over 50 years at a wide range of fluid and environmental operating temperatures. Moreover, PPR exhibit excellent durability in both hot and cold water system. Firstly, it can endure the temperature and pressure strain of hot water system. Pipes are divided into categories. The PN10, it is the thin-walled pipe designed for cold water supply up to 20 C and underfloor heating up to 45 C. Nominal working pressure 1 megapascal or 10.2 kilogram per centimeter squared. Then PN16 is for cold and hot water supply up to 60 C. Nominal working pressure is 1.6 megapascal, 10.32 kilogram per centimeter squared. PN20 is the pipe used for hot water supply, temperature up to 80 C. Nominal pressure 2 megapascal or 20.4 kilogram per centimeter square. Yan ang application niya. So the thermal conductivity of PPR is very low, meaning temperature cannot easily be conducted from the outside environment to the liquid in the pipe, and vice versa. This factor reduces heat loss or gain during the transferring of hot or cold fluid respectively, resulting in energy efficient system and lower installation cost for PPR piping. So, kaya walang isolation saka circulation. PPR piping system, both insulated and uninsulated, have very few low heat loss and allow to meet the required values as can be seen in the following tables. So ito yung table 5 bare PPR piping heat loss. Kinapit ko lang ito based on sa site. So ayan. Nominal pipe size mm sa inches ito. So PL16, so ito yung mga bare piping heat loss. Ito 0 na. So normally, insulation hindi na kailangan. So sizing, instantaneous and semi-instantaneous water heaters. The method for sizing storage water heating equipment should not be used for instantaneous and semi-instantaneous heaters. The following is based on the Hunter method, 1941, for sizing hot and cold water piping, with diversity factors applied for hot water and various building type. Picture units, table 6. Ito yung table 6. Oras ito kanina. are assigned to each fixtures using hot water total. Maximum of hot water demand is obtained from figure 20 of 21 or 22 by matching total fixture unit to the curve for the type of building. So yan. Curve A, restaurant. Curve B, hospital, nursing home, nurses, residence, dormitories, hotels, and motels. Curve C is the apartment and houses. Curve D, office building, elementary, and high school. Makuha mo yung equivalent flow rate niya. So number of fixtures, units, ito fixture units yan. So pag tinotal mo, dito mo sa titignan, makukuha mo yung value. Ito yung enlarge. Yung equivalent flow rate, yung gallons per minute. So, ito na yung sa instantaneous. So, special consideration should be given to application involving periodic use of shower banks, process equipment, laundry machine, etc. as may occur in field houses, gymnasium, factories, hospital, and other facilities. Because this application could have all equipment on at the same time, total hot water capacity should be determined and added to the maximum hot water demand from the modified under curve. Often, the temperature of hot water arriving at temperature is higher than is needed, and hot and cold water are mixed together at temperature to provide the desired temperature. The equation derived from a simple energy balance of mixing hot and cold water shows the ratio of hot water flow to the desired and used flow or for any given hot, cold, and mixed and used temperature. So, hot water flow rate is the mixed temperature flow rate times T mix minus T minus cold divided by T hot minus T cold. So ito yung, yan. These are the hot water demand at 140. Once the actual hot water flow rate is known, the heater can then be selected for the total demand and temperature rise required. For critical applications such as hospital, multiple heaters with 100% diesel capacity are recommended. Consider multiple heaters for building in which continuity observation is important. The minimum recommended size for semi-instantaneous heater is 3 GPM, except for restaurant for which it is 15 GPM. When system flow is not easily determined, the heater may be sized for pore flow of the piping at a maximum speed of 600 feet per minute. Heaters with low flows must be sized carefully, and care should be taken in the estimation of diversity factor. Unusual hot water requirements should be analyzed to determine whether additional capacity is required. One example is a dormitory in a military school, where all showers and lavatories are used continuously when students return from a drill. In this case, the heater and piping should be sized for whole flow system flow. So whereas the fixture count method basis heater size of the diversified system and hot water flow, hot water piping should be sized for full flow. To the pictures. So the circulating hot water system are adaptable to instantaneous heater. To make preliminary estimate of hot water demand when the fixtures count is not known, use table 7 with figure 21 or figure 22. The result is usually higher than the demand determined from the actual fixture count. Actual heater size should be determined from table 6. So preliminary hot water demand estimate. So yan. Fixture unit yan ha. Yan. Hospital or nursing home, 2.5 per bed. Hotel or motel, 2.5 per room. Office building, 0.15 per person. Elementary, 0.3. Junior and senior high school, 0.3. Ito yung mga estimate niya. Any method, makukuha ko yun. So, mga preliminary, actual, detail, yan. Okay. Sample. A 600 student elementary school has the following fixture count. 60 public lavatories, 6 service sink, 4 kitchen sink, 6 showers, and 1 dishwasher at 8 GPM. So determine the hot water flow rate for sizing a semi-instantaneous heater based on the following. A. Estimate number of pictures. B. Actual picture count. Solution A. Use table 7 to find the estimated picture count. So 600 student times 0.3 pictures per student. Andito siya, di ba? 0.3. Yan. Is 180 picture unit. As showers are not included, table 6 shows 1.5 picture unit per shower times 6. So 9 additional picture unit. The basic law is ito sa baba pala, plus shower load. Okay? So the basic law is determined from 4D of figure 22, which shows that for a total of 189 picture unit is 23 GPM. D. Yan, for D. 189, hanapin na 189. Tapos mga tama, 23. Hindi ko na nailagay na sa mga. Okay. Mabilisan na kasi ito. So B, to size the unit based on actual picture count in table 16. The calculation is as follows. At 87 picture unit, 4D of figure 22 shows 16 GPM, to which must be added the dishwasher requirement of 8 GPM. Thus, the total flow is 24 GPM. So that's balance. Comparing the flow based on actual picture count to that obtained from the preliminary estimate shows the preliminary estimate to be slightly lower in this case. It is possible that the preliminary estimate could have been as much as twice the final picture count. To prevent oversizing of the equipment, use the actual picture count method to select the unit.